I don't want to get all complicated with it. I want to keep it as simple as possible, but it can get a little complicated sometimes. So we can keep building from here, and we can keep using this particular data set as we move forward, because it's a good data set. I discovered, I searched and found it, and it is a good data set to play around with. So what I'm going to do tonight is explain the data a little bit so you have an understanding of it. And this was a survey that actually was really done, and I think there's 439 participants in it, and the variables that they collected information on was gender, which they labeled as sex, age, marital status, if they had children, educational level, their sources of stress, if they were smokers, the number of cigarettes they smoked. Then they had several standardized scales. And in the standardized scales, they had an optimism scale, which had these 6 questions. They had a mastery scale, which had 7 questions. I never know how to say this correctly. I've actually used it in my research, but I don't think I ever say it correctly. The PANAS scale, PANAS scale, which is a feeling emotion scale, which is these 11. I think there's 11 there. 20 questions. Yeah, there's 20 questions on it. The life satisfaction scale, perceived stress scale, I've used that one in research before also, and the self-esteem scale, the social desirability scale, and the perceived control scale. And why I wanted you to see this is because if you're using scales that ask multiple questions, when you design your questionnaire for individuals to fill it out, you will have each individual variable, you'll have, each question will be like an individual variable right there, but then you're actually going to have to sum that scale, and that's where they come down here and they create a new variable. So there's their total optimism score for each participant, their total mastery score for each participant, their total positive affect score, negative affect score, life satisfaction. So when you go back up and you look at these variables right here, these are the individual questions that the participants completed on those scales and was entered into SPSS. And then they have transformed those into a new variable to give it the real variable that you're going to work with. What I'm going to try to do is build some activities so you can see how to recode variables, to do this, to take your variables, and if you're using scales and make it into the variable you're going to use, because I'm assuming you haven't done those things. And this is part of that cleaning up the data and getting it ready for analysis. What we're going to use tonight, we're going to use the scale that they have labeled as sex, which is actually gender, and they have it listed for males and females. 1's males and 2's are females, okay? We're going to use total mastery, total perceived stress, total self-esteem, total social desirability, and we'll use the new education categories where they recoded those so that we can run the Anova. What happened here is they have their education categories up here. And what they collected for their education categories was primary school, some secondary, completed high school, some additional training, completed undergraduate, postgraduate completed. Those were their categories. And then what they discovered was they had in these first couple of sections, they have very low responses. So they recoded that to make it a more meaningful variable. And it is down here, this education recode. And you can see they recoded their responses into did not complete high school, completed high school, some additional training, completed undergrad, completed postgrad. And it's somehow in there they skipped completed grad altogether, but I don't, that kind of has bugged me, but I'm trying to get over that. This is their data. But that's how they recoded that, because they only had a few responses in those first categories. And so this helped make it cleaner for them to look at. So we're going to use this variable also. So what we're going to start with tonight is we're going to start with just taking a look at how the variables, what they look at. You always do your descriptive statistics first, just to get an eyeball on your different categories, okay? Now, I've already put these over here. So when I went to analyze and I went to descriptives, I went to frequencies, I went ahead and moved these variables over here because I'm interested in looking at the gender, education recode, self-esteem, social desirability, perceived stress, and total mastery. Those are the ones that I want to use tonight. Now, if you'll notice, I have two or actually three different levels in here. I've got scaled instruments, I've got a nominal level, and I've got a ordinal level. But since I'm running them all together and don't want to run them individually, I went ahead and said, give me the mean, the median, the mode for all of them. Give me the quartiles, give me your standard deviation, your minimum, maximum, the range, the skewness, kurtosis. Now, this is not going to apply to the ordinal level or to the nominal level, but it will apply to those that are scale.
Dr. Judd,
Do
you mind slowing down just a little bit so I can follow along with you in SPSS?
Okay.
I have it pulled up. I just didn't get all the variables moved over in time.
Okay, so here's your variables that we want to use.
Okay.
Use gender, which is labeled as sex. The education recode, which is down towards the bottom.
Oh, okay, sure, I see it.
Okay, total self-esteem, again towards the bottom.
And mastery. Okay, cool. I've got it. Thank you.
You get them? Okay. Yeah. So you're going to click on statistics, and you're going to just pretty much ask for all of it. And again, it's not going to apply to those nominal ones, so we're going to ignore some of what we get. But you've got the mean, the median, the mode, standard deviation, your range. You always want your minimum and maximum, because you may get a range and it may say you have a range of 10, but that doesn't tell you anything. Is it 10 between 1 and 10, or is it 10 between 2 and 20? So you need your minimum and maximums in there, and you want your skewness and your kurtosis, okay? And then you can actually go to your charts. You can click on charts, and you can click on histograms, and you can click on show the normal curve on the histogram, okay? So then if we just click on OK, we're going to get a whole mess of stuff, right? So right here, we have our statistics in this first table, and it shows us mean, median, mode, standard deviation, skewness. It shows us all of that. For gender and education recode, we just ignore that because it's not meaningful, because those are not the level of variables that has any meaning on, okay?
Dr. Judd, were we supposed to be seeing right now the results from the analysis that you just pulled?
Yes, and how did you tell me to do that before? A new share, that's it. Let me find it. Okay, I think this is it. Now, can you see it?
Yes, ma'am. Thank you so much.
Thank you for doing that. Thank you for catching me. I forgot all about that. Okay, yeah. So the first table, you have your statistics, right? And there's your mean, your median, your mode, standard deviation, and all of that. The self-esteem, social desirability, total perceived stress, and total mastery are at the scale level. So we can see the mean for self-esteem is 3, social desirability, oops, I'm sorry, that's missing. The mean is 33.53 for self-esteem, 5.30 for social desirability, 26.73, 21. So we can see those. We've got the median, we have the mode. Mode is not really important when you're talking about scaled scores, so just disregard that. Mode here is not really important because we only have 2 categories, right? And the same here for education recode. So this doesn't mean anything here, but on these 4 is what we're interested in. We have the range down here at the bottom. Okay, so we have a range of 22 for self-esteem, and it goes from 18 to 40. When we look at, and the range on the scale is from 10 to 40. Okay, so from 18 to 40, we can just kind of eyeball that and say our participants are they're all going to have some pretty good self-esteem in there, right? Because nobody's all the way down to 10. Total social desirability, it ranges from 0 to 10. And we've got the full range there in our responses. Total perceived stress, it ranges from 10 to 50. And we have from 12 to 46. And then total mastery, it would range from 7 to 28. And we have from 8 to 28. So we have a good range in there also too. So this gives us our range. It gives us our means. And look here at our mean and our median. If we look at total perceived stress, our mean is 26.73 and our median is 26. What does that tell us? We really don't have a lot of skewness there, right? That's going to be pretty close to some normal distribution. Right here, we have a mean under total mastery of 21.76 and it wouldn't do that. And 22 for the median, that's going to be really close. Same for total social desirability. And then self-esteem, we have a little bit of difference between the mean and the median, and it looks to be negatively skewed a little bit. So this gives us information, just the first, right off the bat, we have some information about our variables to start with.
Dr. Judd.
Yes.
Okay, quick question on that. So on any multiple regression, particularly this one, we will always do descriptive statistics beforehand. Okay. And when you ask, like on our homework, to report the model assumptions, are you talking about the descriptive statistics or are you talking about the model summary?
Okay, Carla, you're getting ahead of us. We're not to multiple regression yet. Okay. This is just descriptive.
Sorry.
No matter, that's okay. That's a great question. No matter what you're going to run, whether you're going to run t-test, Anova, whatever, you always start with descriptive statistics. Okay, because that puts your eyes on your data. So you're going to know, do you have big outliers you got to turn around and find out about? Do you have missing data you need to find out about? It's that cleaning process that starts. So no matter what you do, no matter before you start any statistical analysis, always run descriptives. Okay, this is where we get an idea about our sample. We start learning about our sample population by doing this, okay? So yeah, we're not to multiple regression yet. So this is just the beginning point no matter what you're doing, okay? So we have that there. Then we have for gender, and so this actually is meaningful. It shows us that 42% of our participants are male and 57.9% are female. Education, recoded. We've got 12.5% of our participants did not complete high school, 19.4% did, 27.3% had some additional training, 28% completed their undergrad, and 12% completed their postgrad. So this also gives us a picture of our sample. And look here, we have 439 participants, 439 participants. So we have no missing data right here. We don't have to worry about missing data because that's all accounted for right there. When we come up here, let's just hop back up here to this statistics. And let's look at our numbers, the valid numbers across the top. We have 3 missing for total self-esteem. We have 6 missing for total social desirability. We have 6 for perceived stress, and we have 3 for total mastery. That missing data is not enough to worry about, okay? If it's less than 5%, it's not anything to worry about. So just looking at this, we're not going to get concerned about missing data or having to do anything with that, okay? Then you get your percentages, you get your cumulative frequencies, and these are helpful again for you to kind of see how your data is falling. So on total self-esteem, we have participants scoring from 18 to 40. 40 means you have the highest self-esteem you could have. 10 means you have the lowest self-esteem you could have. So they're starting at about 18 to 40, our participants are. How I typically use this is I begin looking for that 50% mark. and kind of see where we're at. 47.9% of our participants scored 34 or below. So almost half of our participants were 34 or below on the self-esteem score. And that means almost half of our participants are going to be between 35 and 40. So 50% of our participants, close to 50% of our participants are going to have some high self-esteem. Just looking at that midpoint right there and where that score falls, I can see there's going to be some skewness there. Okay, it's going to typically, the longer tail is going to go towards that smaller end. So it's going to be skewed more positively. Our participants tend to have a higher self-esteem. The majority of them do. So that's what that tells me right there. Social desirability, I do the same thing. I come in here and I kind of look for that 50%, and we have scores from 0 to 10. So 5's about midpoint. Just a little over 50%, 55% have scored 5 or below, which means about 45% have scored 6 or above. So that's pretty balanced in there. Same for perceived stress. I just start around that 50% to see where we're at. And we've got it could be from 10 to 50. So they start at 12, they go to 46. Somewhere around 50% are going to be 26 or below. 50% are between 27 and 50. So that's about 50%. So that's a nice balance in there. And then total mastery is going to be similar to the same thing. Again, this is eyeballing it. Sometimes it's very meaningful to report these percentages. Specifically, I would go back on the self-esteem and I would make a note that, 50% of the participants are going to be at the upper end of that self-esteem scale. So when I explain my results, I'm going to make a note of that. That's something that's important that I think needs to be taken into account when this analysis happens. You as the researcher know your data and you know what's going to be important. So you're going to pick out different things. There's some things that are very standard, but you're going to pick out different things to actually explain and tell the story of that sample because you're going to know your data. So I think one of the hardest things about this is I can't tell you to always do the same thing every single time because it depends on what relationships you're looking at. It depends on what your variables are. It depends on what's important in that data. So then when we come down here, we ask for our histograms and our normal curve. We have our categorical variables come up because we just ran them all together. So that's really not meaningful right there. The education, that's not meaningful right there. So we can ignore that. But see, we can come down here to our scaled, and then we can see the image here of our self-esteem. We already knew it was going to be kind of skewed towards this way because the majority of our participants, or half of them, are going to be at this end of the scale. So we can visually see, this would be the normal curve, and we can visually see that more cases are concentrated toward this side. So we know we have an issue right here. We have a problem. At some point, we may have to decide to do something with it, or we may choose to leave it that way. Social desirability, again, we saw in our numbers with our mean and our median, that it was a little bit more balanced. So it actually more approximates the normal curve. So we don't have real concerns there. Perceived stress is the same thing. We have a little bit of skewness over here in terms of higher levels of perceived stress, but probably not enough to be really concerned about. In total mastery, looky here, we've got some skewness going on here, but it really didn't show that in our numbers up there. It just kind of showed it visually right here. So in seeing that, as the researcher, as the data analyst, I have to say, is this going to affect my outcome? Do I need to do something with this? Or do I go ahead and use it and then provide in the results that there was some skewness there? Right here for this total mastery, I would go ahead and tonight we're going to go ahead and use them all the same way, but I would go ahead and use it because there wasn't a huge difference between the mean and the median up there. There was just a few points difference. So, but this is the first step. It's always looking at the descriptives of what you're going to be running. So you can get that picture of what's going on with that sample population. And then you can start identifying potential problem areas that you may need to go back and dig back into. Does that make sense? Okay, no matter what you do, you always begin with descriptives, okay? Okay. Now let me re-share my screen. Okay, so we're back to the SPSS now. You can also, if you go to Descriptive Statistics, you can also go to Explore, and it's just another way of looking at it. And this will give you some linearity type of things. So you could take you could take total self-esteem and social desirability, put it in there. You can go to your descriptives. You could ask for outliers. You could ask for your normality plots and your test, your stem and leaf. And I'm gonna tell y'all up front, I ran this. It doesn't come out very good. It's not very pretty. I don't know what the problem is. I haven't figured it out yet. Because for some reason it breaks it down into the individual scores right there. But you can do this and it'll give you a stem and leaf plot so you can kind of see where your scores fall. You know, you want it to be a nice little kind of triangle right there, and you can see we don't have that. So this is another visual that you can look at. You can also look at these.
Dr. Judd,
Yes.
your output's not showing again.
My what? Oh,
The output for SPSS.
I always forget that. Thank you for telling me. Okay, now is it showing? You see the QQ plots? Okay. So this gives you, again, some visuals to see where you might have some problems in terms of linearity. You want linearity. You want the relationship between the two variables to be a straight line, not curvature right here like this. So we could have a potential problem, maybe not significant enough to do anything about, in terms of our relationship between self-esteem and mastery. So again, it's another visual checking that you can do to look at that. Ugh. Now, okay. All right, so let's decide. I want to start with the independent samples t-test, okay? An independent samples t-test is run to look at the difference in mean scores between two groups, two independent groups. All right. So based on what we have, based on what we've chosen tonight, we're going to look at an independent samples t-test for self-esteem, perceived stress, and mastery. Were those one? Yeah, perceived stress. Let me just choose one of them. We're going to look at the difference between perceived stress and self-esteem between men and women. I'll keep it simple. Okay. So I've got two independent categories. I have male and females. They're independent of each other. One can't be in the other according to this. And we're going to look at the difference in mean scores. So I'm going to say compare means. All right. Under analysis, compare means. I want independent samples t-test. And when I click that on, let me move these over here so I can walk y'all through this. Okay, so my grouping variable are going to be my two categories. So I'm going to put my gender over there. And you see these little question marks right here? I have to tell it which categories to use. So I have to define group. They labeled males 1 and females 2. So I tell it to use group 1 and group 2. I only have 2 groups. Now, if I chose to put education recode in there and I have 5 groups, I can choose any of those 5. I can put any of those, I can compare undergraduate and the postgraduate, or I can compare high school or whatever, but I can only compare 2 groups. And so I put the corresponding number in there. So for this one, I'm putting males and females. And then we decided we're going to look at, which 2 did I say? Mastery and perceived stress. So I want perceived stress as a test variable, and I want total mastery as my perceived variable. All right. So I'm testing the difference between the mean scores on these 2 variables between males and females. I click on my options. This is the default, exclude cases analysis by analysis. And what this tells us is that if there's missing cases, it tells us to look at each case individually. So SPSS is going to look at each one. And within that, if there's one that is missing, it'll eliminate that particular case. We almost always go analysis by analysis. If you go cases list-wise, then it excludes any case that has a missing variable in there, period. Now, there's some reason to do that sometimes, but the default of exclude cases analysis by analysis typically is okay. And that just takes care of any missing variables that would impact this. Okay, so we're going to look at total perceived stress, total mastery, and gender. We're going to hit okay. And then I'm going to come up here and I'm going to do a new share. Look at there, I remembered. And I hope I'm pulling up the right one. Okay, so you should see group statistics, independent samples t-test, and then we have the effect sizes down there. We're not going to worry about this tonight. So up here, we actually see that our total perceived stress, our male mean was 25.79, and our female mean was 27.42. On total mastery, we see the male has a little bit higher mean of 22.3, and females have a little bit lower of 21.37. So that gives us our mean and our standard deviation. Anytime you report the mean in your results, you have to report the standard deviation. They go together. You never report a mean without a standard deviation. So these are important right here. So then we come to the independent samples t-test. The first part here is this Levine's test for equality of variances. And what this tests for is homogeneity, okay? Let me find my notes here so I tell you absolutely correctly. Homogeneity of variance, so meaning that both groups have the same variance, is important for the t-test, okay? So this Levine's test of equality tests for that for you when you run the t-test. You see you have 2 options here. You have equal variances assumed, and you have equal variances not assumed. You're going to choose one of those. Your equal variances assumed, I want to make sure I get this correct, so I'm looking at my notes. If the p-value is large, which is over 0.05, it indicates the variances are equal across the 2 groups, and we use the first row of the output. So right here, we have a 0.165 significant. That's over our standard 0.5, so it's a big p-value. So we're going to look across here to determine if we have significance. All right, and we do, because it's 0.004, which is less than 0.05, right? So we do have significance between perceived stress, meaning there's a significant difference in the mean score between males and females on their perceived stress scale. If we looked at total mastery, we go to Levine's significance level, it's 0.024. That's less than 0.05. So we're going to look at the bottom row and make our determination. So in the bottom row right here, we have a 0.013, which again is still significant, right? Because it's less than 0.05. So there's a significant difference between total mastery between male and females. That's how you determine homogeneity. This runs for you in the independent samples t-test. If your significance on your Levine's is over your 0.05, if it's a big number, you use the top row to make your determination. If it's below 0.05, you use the second row to make your determination. It just tells you which row to look at to determine if you have significance or not. Okay? Any questions on that? And I did a quick write-up for it. So let me do a new share. Can you see my Word document? Okay. So for the t-test right here, this would potentially be how you would write your results, just your results. An independent samples t-test comparing the mean scores of mastery and perceived stress between male and female participants found a significant difference between the means of the two groups for mastery. And you'll see where you have mastery, you put your degrees, your T, your degrees of freedom, there's your T-score, there's your significance level, and perceived stress, same way. Degrees of freedom go in parentheses, your T-score, and your significance level, okay? The mean for male participants was significantly higher because the mean was 22.30 with a standard deviation of 3.57 than the mean for females, which was 21.37 with a standard deviation of 4.2 on mastery, while the mean for female participants was significantly higher, and you put your mean and your standard deviation in there for your female when compared to male participants' mean and standard deviation.
Dr.
So,
Johnson,
yes.
Can you email that? Did you email this?
I did not email the write-ups. I'm going to put these together for y'all for tomorrow. So you will have exactly what we did as well as these write-ups, okay? In terms of what you have to pull out of there.
Okay. Thank you.
But those are the things that what you have to learn is what's important in the tables to, number one, as the data analyst, to make decisions about the data, if you need to do anything to correct it or whatever. And then number two, what you have to pull out to report. So that's what I want to give you an example of that every time. So that really is screen sharing is paused. Zoom share. Okay, let me bring that down and let me get rid of this. And then let me bring back up my data. Okay, so my data should be back. Is my data back? Okay. That right there is a t-test of independent. That's an independent samples t-test. Okay. The assumptions are that you have two independent groups. They can't be in both groups at the same time. Your variable is on an interval ratio scale. Both of them are. Okay. You have the homogeneity of variances, which the Levine's test for that. There's going to be correlation between it. And so, remember, did that pull up the correlation? I don't think I pulled up the correlation in that. Okay. So the other assumption for that is that they have to be correlated, meaning that when one changes, the other changes. So one of the things that you may want to do when you look at, before you run a t-test, you may want to go to correlation. And we ran mastery and self-esteem. Let's just see. I'm just going to do this real quick. So we do have a correlation here. So we have a significant correlation between the two. So that's an assumption of the t-test. The variables have to be correlated, meaning when one changes, the other changes. You get that with your Pearsons, okay? They have to have be at interval ratio level. There has to be two categories that are independent of each other. They have the homogeneity. There's no outliers. We check for that on our descriptives. There's no outliers. There's no significant missing data. So those are the things you look for, and then you run your t-test. The t-test is pretty robust and can withstand some violations of those assumptions without giving you false information. Any questions on the t-test?
I have a question. I think it's applicable to both the t-test and the regression, which I don't think I worded it correctly earlier. But when you are, okay, so now when you're asking for model assumptions for whatever test, I guess.
Model assumption is only on regression.
It's only on regression. So you're not
asking. Wait a minute. I'm sorry. I was thinking model summary. Model assumptions, yes, some apply. Not all of them apply to all tests. Yes, you're correct. So the model assumptions have to do with the theoretical aspects of the test, like the homogeneity, linearity, homoscedasticity, if there's any outliers, if there's any missing data, all of that comes into those model assumptions. Some tests are robust enough to handle some violations of those assumptions. So even if you have small violations of them, you're okay. Multiple regression is not one of those. Multiple regression, you really have to work on your data for those model assumptions. Okay.
So, okay, well, I'll ask that when we get to that then. Okay.
Yeah, but yes, you're correct. Model assumptions, you want to go through that list no matter what you're running to see if you need to address any of those.
Okay.
You are correct. Absolutely. I was thinking when you said that, in my mind, I went to model summary, which is the output for the multiple regression. That was I confused that.
Well, and I was confused about the difference between the two, which is why I'm trying to figure that out. So thank you. Thank you.
Yeah. And model assumptions are just the things in cleaning your data that you need to make sure your data meets those assumptions as close to possible so that when you run your statistical test, you'll get accurate outcome. Okay. Because if you have, say you have a lot of systematic missing data for some reason, and so you start running different tests, your results that you get may not be accurate because you didn't account for all that missing data. Or you may have, you won't have normality. You'll have really big skewness. Everything will come over to one side of that curve, one or the other side of that curve. And if you don't do something with that to clean that up and you run multiple regression or you run some of the other tests, the outcome you get will not be accurate. Okay, so that's those model assumptions, yes, on that part. Okay, so the next test that we're going to do is we're going to do an ANOVA. And an ANOVA essentially does the same thing as an independent samples t-test, but with 3 or more groups. Okay, if you wanted to compare 3 or more groups, you could do multiple t-tests. So let's just say we had male, female, transgender. Let's just say we had 3 groups instead of 2. We could compare male and females on perceived stress, and we compare male and transgendered on perceived stress, and then we could compare female and transgendered on perceived stress. So we could do multiple t-tests, but what happens is you run the risk of creating the type 1 error when you do that. So ANOVA is a statistical procedure that will take into account 3 or more groups, but it's going to do essentially the same thing that the t-test does and look at the mean between 3 or more groups. So for the ANOVA, we're going to come over here to Analyze. And we're going to go to compare means again, because we're comparing means for groups. And we're going to go down here and we're going to go to the one-way ANOVA. And when the one-way ANOVA comes up, we have a dependent list and we have a factor list. Our dependent list is going to be our scaled, our dependent variables. And then our factor one is the one is going to have the different groups. So let's just use this, and let's use the new education Recode down here at the bottom. Whoops, sorry, wrong place. It's going to be the factor because it has the groups. It has less than, high school, college, whatever those were. And let's just do perceived. No, let's go to mastery. Because logically, if you were postgraduate, you should have higher levels of feelings of mastery, maybe, okay? So we're going to check the mean score of each of these different categories on their mastery test. We're going to go to contrast, and actually we're not going to pick anything here. This is all default, so we're going to cancel that. We're going to go to post hoc. And when you go to post hoc, you want to pick Tukey, T-U-K-E-Y, Tukey. The post hoc test is important because if you don't run the post hoc test, you can get a significant finding, but it won't tell you the groups that the difference is in. So you have to have Tukey because it goes in and analyzes the difference in each individual group. So you've got Tukey, all right?
I personally like the Bonferroni, just saying.
Do what?
I said I personally like the Bonferroni, just telling you.
Oh, I see. I was trained on Tukey.
I was trained on Bonferroni, so that's why I was saying that.
Isn't that funny? So we'll do descriptives. Yeah, let's just use that for right now. Now, see, you're going to make me dig down and find out what the criteria would be to use one over the other. Or if it's just a matter of training, but. Okay, so we're going to do this. So we've got our descriptive statistics again, right? Did not complete high school, completed high school, some additional training, completed undergrad, completed postgrad. We have the numbers, all right? We come up with 436. Well, so that tells us there was 3 that was missing, but it didn't include them in here. We have the mean on our mastery scale of
Dr. Jed,
yes.
it's not showing your own.
Thank you, thank you, thank you.
Sorry. Yeah.
No, thank you. Okay, I think this one's it. Okay, you should see descriptives, total mastery, do you? Okay, yes, thank you for reminding me. So you have the mean for each of your groups here on their total mastery and their standard deviation. When you look down here, you've got your actual range. So did not complete high school, they ranged from 8 to 28. Those who completed high school ranged from 14, a minimum, to 28. And this gives you your minimum, your maximum range. You've got your ANOVA table. And of course, the first thing we always look at is, do we have a significant relationship? And we've got a 0.032, which is less than 0.05 for it, so it is significant. We have our degrees of freedom, which we're going to have to report. We have our F score. Okay. So then we have to come down here and then we have to determine where the differences are. Because we have 1, 2, 3, 4, 5, 2, we have 5 categories. So where are our differences? So right here, we have did not complete high school compared with the ones who completed high school, additional training, undergrad, and postgrad. The only one that we have that's significant is right here. So there's a significant difference in the level of mastery between those who did not complete high school and those who completed their undergraduate degree, because we have a 0.013 right here. So if we go back up and we look at that mean, did not complete high school was 20.43 and completed their undergraduate degree was 22.48. We would say that those who completed their undergraduate degree significantly differed from those who did not complete high school on their mastery score, and it was higher. So let's see, we've got completed high school in the next evaluation. And again, it compares it with each one. So this actually can become a matrix. You can present it in a matrix because they compare with each one. And for completed high school, we don't show that there's a significant difference between any of them, do we? Because they're all above the 0.05. Some additional training, we don't show that there was any significant difference, right? It's all above the 0.05. And we've got our significant difference here again. It was already reported in the first one, and then completed the postgraduate. So really the only groups that is significantly different on their level of mastery is the difference between those who did not complete high school and those who completed their undergraduate degree. Y'all see that? How you break that down? So there's only one in all of those. You would, and I did not write this one up. I have to write this one up for you and send it to you, but you would report one significant finding and you would report the rest as being not significant. Even though there's a slight difference in their scores, there's only a significant difference between feelings of mastery for those who did not complete high school and those who completed their undergraduate degree. That's your ANOVA. Pretty straightforward, isn't it? Just remember to do the ad hoc, otherwise you'll get it and you'll say, well, I don't know where the differences are. So you have to do the ad hoc, like I said, which I use Tukey on that one. I will write that up for you and I will give that to you, but I didn't write this one up. Any questions on the ANOVA? Follows the same, you go over the same kind of assumptions that you did with the t-test. Okay, so let me share my screen again. Okay, so now we're going to run a multiple regression. And for the multiple regression, what did I use? Okay, I used self-esteem as my dependent variable, and I chose mastery, perceived stress, and social desirability, because to me, those were kind of logical. So I wanted to know how much those contributed to the variance in self-esteem among my participants? So I'm going to, this always comes down. I'm going to go to analyze. Can y'all see my SPSS again? Okay. I'm going to go to analyze. I'm going to come down to regression. Okay. I'm going to choose linear. Okay. And I already have my variables over here. My dependent variable is my total self-esteem. My independent variables are going to be mastery, perceived stress, and social desirability. My statistics, when I click on that, I need the model fit. I need the R squared. I go ahead and grab my descriptives again. Collinearity Diagnostics, the Durbin-Watson, and then I get my regression coefficients. I didn't put my plots in there. We'll learn how to do the plots later. I think that's all. Everything else, exclude cases list-wise. Now, this is the default exclude cases list-wise because you don't want to include cases that have missing data in one of the variables. If they have missing data on all the variables, you want to exclude them. So this is multiple regression. It's the default for exclude cases list-wise. So you just leave that as that. So then when it comes up, and this is what we get. We've got our correlations right here. And we show that we actually have significant correlations across it. We have significant correlations with self-esteem and mastery. We have a significant correlation with mastery and total perceived stress. And we have a significant correlation with perceived stress and total social desirability. So we have significant correlations here. Perceived stress, we have
Dr. Judd.
Oh, I'm sorry. Thank
I'm
you.
so sorry.
Thank you. There we go. Okay, back up. So we have our correlations first. All right. And on this second row is our significance level. And you can see right here that we actually have a matrix where they're all significant correlations. Self-esteem is significantly correlated with total mastery. Total mastery is significantly correlated with total perceived stress. Total perceived stress is significantly correlated with total social desirability, and total perceived stress and total self-esteem is correlated. So we have the correlations right there. And up here we have our correlation coefficient. So we know that total perceived stress and total self-esteem have a negative moderate correlation. And that would make sense. As stress goes up, self-esteem goes down. That's what that's telling us. There's a moderate correlation that as stress goes up, self-esteem goes down. There's a moderate negative correlation between as stress goes up, mastery goes down. Okay. And of course, perceived stress is 100%. And then there's a negative correlation between social desirability, a weak correlation. It's 0.228, but it's negative. So again, as perceived stress goes up, social desirability goes down. So those theoretically, those are logical. And so in looking at that, you can say, okay, that's kind of making sense. As one goes up, the other goes down. So you have the negative correlations here, but they're all significant. Okay. So now we get to our model summary. And this is what I confused Carla on a while ago. So we get to our model summary. And we look at our adjusted R squared, and it's 0.394. So essentially, close to 40% of the variance in our self-esteem is being explained by perceived stress, mastery, and social desirability. It is significant, okay? And we've got our F score. Oh, here we go. Here's our Anova table, which is the second thing that's important to us. We need our F score out of it. We need our degrees of freedom. So we have 3 and 424 for our degrees of freedom. We have our F score. We have our significance right there. Here is for our equation.
Dr. Judd, can I ask you a question?
Absolutely.
For the model a summary, are you only looking at the adjusted R?
Yes, for what I wrote up tonight, yes, I'm just looking at the adjusted R. The standard error of the estimate is what happens in one standard deviation. So 68% is explained within the 4.175, and then 96% is explained within what it be 2 times that, 8 point something. So you can explain that, but for what I wrote up tonight, I did just look at the adjusted R squared.
Okay, that's fine.
Yeah.
Thank you so much.
Can we use the R square as well, or like when we write this up?
No,
Or-
you always use your adjusted R squared. You always report the adjusted R.
Okay.
Mm-hmm.
Dr. Jed,
Yes.
kind of on that note, what's the difference? Like, what is the adjusted portion? What's adjusted about it? Are they separate things?
The adjusted R squared, and I'm going to have to go back and get you a true definition of it before I explain it. It does take into account the residuals in terms of the variance in those.
Mhm.
I will get you a clear definition between the two, but you always report the adjusted R.
Thank you.
Okay. Oh, and then back up here, the Durbin, to check for independence. Independence is one of the model assumptions, that there's independence in the values, and that typically can go in terms of time or geography. So like when they were collected and things like that. If the Durbin-Watson is right at 2, then it's independent. There's no concerns. And if you round this up, you're going to get a 2. So there's no concerns in terms that these are not independent or that there's a problem in the way the data was collected. So that checks for independence. Collinearity Diagnostics. Now this one is a little bit trickier because we have some high numbers here. But if you look at your condition index for your collinearity diagnostics, you look at this condition index right here. Anything below I think it's a 10. Yeah, anything below a 10, it's good. There's not a problem. We have a 28 here. And anything above 15 can indicate multicollinearity, which means it can actually be highly correlated with one of the other measures. Then when you see that, you're going to come over here and you're going to look, and we have these high scores right here, 0.7, 0.76, and 0.79. But the rule of thumb tells us that if anything's below 0.90, if everything's below 0.90, we really don't have to worry about collinearity or multicollinearity on that. This is one that if I was doing a deep dive, I may actually go deeper into because of that very high, that 28 right there on that condition index, which tells me that there is a dimension that's going to be like on this total mastery and total perceived stress and total desirability. Those dimensions could be highly correlated in essentially measuring the same thing. But right here, anything below a 10, you don't have to worry about, and anything above a 15, you want to investigate a little more on your collinearity diagnostics. So it gives you that.
What if, I'm sorry, Dr.
Go
Judge.
ahead.
You said that anything below a 10, it will be okay, but anything above 15, we would have to look at a. What about if it is in the middle, around like 11 or 12?
You know, it becomes a judgment call. Yeah, it becomes a judgment call in terms of your data. And if your data is large enough, it's probably going to be okay. If your sample's large enough, it's, you know, those are always, they're not exacts, okay?
Mhm.
The Durbin-Watson is pretty exact. They'll tell you you need a 2.0 to show that everything's independent. The others are kind of ranges. And so it depends upon your analysis. When it comes time to report what you've done, to write up your findings and to report what you've done, if you found that, but you determined it really didn't impact your outcome, you would want to acknowledge it. Okay. You want to just ignore it. You would want to acknowledge it. If you find it and you do make some changes in terms of doing some data, and we'll get in, I don't want to get into the complicatedness of it because I got to practice it again. I had to do it on my dissertation, but you actually have to do some data adjustment on that. Then you have to also explain that. You really want to try to avoid doing any type of restructuring of your data if at all possible. You want it as clear as possible, but it truly becomes a judgment in terms of how you think it's going to impact that. And when you're writing your results, and if you decide that it's not going to impact it and that you're going to use it, you want to find a reference from a book or something that supports that. So it's not just your decision, but I got this decision from Tabernac and Finch because they say that if it's this sample size and if it's this, then it's okay, you know. So anytime you make those decisions, those statistical decisions, you need a reference to back it up.
Okay.
That makes sense.
Thank you so much. Yes. And can you just review again just the variance proportions?
Where at?
On the collinearity diagnostic.
Okay, yes.
The part on the right.
Right here.
Yes. Mm-hmm.
Okay. Yeah, the variance proportions. If any of these are 0.9 or above, 0.90 or above, it's just a secondary diagnostic to support this right here to say I really need to figure out what's going on. Okay, but because this was 28 and it's above the 15, but none of these were 0.9 or above, that's what's telling me that there's something wonky in there, but it may not truly be multicollinearity. So that's what you look for right here, is anything that's 0.90 or above. It's a second diagnostic tool to go with the condition index.
Okay, so I guess I'm so sorry to take time with
That's
this,
fine.
but I guess then if it was 0.9 or above, then it would corroborate with your findings. It would strengthen it. Is that what it is?
No. It's going to strengthen the fact that you have multicollinearity going on, and you need to figure out what two variables are highly related, are being correlated. Okay, so you look at your condition index, all right? So let's say all of these were under 10. Then that's the first thing we look at, and we're like, okay, we're good, we're moving on. But we look at ours and we see we've got one that's 28. Ooh, that's above what it should be. So then the second thing we do is we come over here and look at these variance proportions. Is any of those 0.9 or above? If so, then we really can't ignore that. We have to go back and we have to actually do, it could be a Manitoba distance. We're going to have to do something with that because it's going to impact our outcome if we have those two indicators that we have multicollinearity.
Okay.
So it's really two indicators.
Okay.
Does that help?
Yes.
Kind of.
Yeah, I'm sorry. It's just,
No, that's fine.
but then how would we investigate further? Does that mean that there's something wrong with our data?
It means that in this particular analysis in your regression, you have two variables that are highly correlated and probably measuring the same thing.
Oh.
Okay, so probably we may have mastery maybe measuring the same thing as total social desirability or something like. There's something in your measurement scale that are essentially measuring the same thing. That's what it's trying to tell you, because then you're going to get elevated numbers because you're measuring the same thing with one.
Okay, and that is if it is 0.9 or above. Is that
Yes.
correct? Okay.
Yes, yeah. If you have one of these over 10 and you have one of these over 0.9 or above, you're going to have to dig deeper and find out what's going on.
Okay. Is it a good, for example, is it a good thing that they're both kind of measuring the same thing?
No, no, you do not want that. No.
Okay.
No,
Okay.
In multiple regression, you need to have your independent variables correlated with your dependent variable, but your independent variables should not be correlated with each other, because you're trying to determine how much variance each one of those is contributing to that dependent variable. And if you have two that are very correlated, kind of measuring the same thing, it's going to skew what's contributing.
Okay.
Okay. So
Okay.
independent variables should be correlated with dependent variables, but the independent variables should not be correlated with each other. They should be independent of each other in multiple regression. We're talking strictly multiple regression.
Oh, okay. So we're only talking about if they're, for example, because in this case, it looks like we have three variables: total mastery, total perceived stress, and then
Social desirability.
Yes. So we want all of
all
them
those to be independent.
and to be very distinct from each other.
Yes.
Okay.
Yes. Yes.
Okay.
Yeah, because
That's
they need to be distinct from each other, so you know what they're contributing to that prediction equation.
Okay.
If they're close to each other, then you've got two measures in there measuring the same thing, and it's not going to give you a true. You can't say that each one's contributing independently.
Okay.
To that. Does that help?
Yes, a lot.
Okay.
Thank you so much.
Okay. Now, I did do a write-up for this, so let me pull that up. So on my regression, I wrote, a multiple linear regression was calculated to predict participants' self-esteem based on their scores of mastery, social desirability, and perceived stress. I did all three whenever I did mine, and so sorry, I didn't do just the perceived stress, but a significant regression equation was found. Okay, right here, I say I'm going to report my F score. And my degrees of freedom, I have 3 and 424, is going to equal the 93.702, which is my F score, and I have a p-value of 0.000 with an R squared of 0.394. That's my Anova. That right there is from the model summary, the R squared, and then the F, the significance, and the degrees of freedom all come from the Anova table. All three variables contributed significantly to the prediction. Participants' predicted self-esteem score is equal to 30. These are your coefficients now, 33.210 minus 0.347 times perceived stress plus 0.052 social desirability plus 0.429 times mastery. And I apologize because I didn't run all of those when I did the example here. but I will send you that example. But it's the same thing we did before. You pull those numbers out to get that prediction equation. So if you were actually looking at 3 variables on that, or did we do all 3?
Mhm.
Did we? I've confused myself. Okay, we did do all 3, didn't we?
Yes, I think so. Yes.
Yeah, okay, right here, yes. So that is where I got the numbers. There's my coefficients where I plug the numbers in to my formula. My R squared that I plugged into my formula. So yeah, okay. A multiple regression was calculated to predict participant self-esteem based on their scores of mastery, social desirability, and perceived stress. Okay. A significant regression equation was found. I report my degrees of freedom, my F score, my significance, and my R squared. And essentially what that R squared tells us is that 39% of the variance in self-esteem scores can be explained by those 3 variables. So we can't explain 60% of the variance, but we can explain almost 40%, and that's a pretty good amount to be able to be explained. So all 3 variables contributed significantly to the prediction. Participants' predicted self-esteem score is equal to 33.210 minus 0.347 times whatever their perceived stress score is, plus 0.052 times whatever their social desirability is, plus 0.429 times their mastery. That way you can predict based on participants' scores for mastery, social desirability, and perceived stress, you can predict their self-esteem score. That's what regression does.
Dr. Judd,
Yes.
I don't mean to be just like hooked on the homework 2 assignment, but I've got a question about this question, which is on the PowerPoint you gave us on multiple regression. The model that you had used did not include the collinearity diagnostics or the residual statistics. Do you want us to include that when we
No,
do
you
it?
do not. You do not have to. No, because we haven't gone over that yet. No.
Okay. Thank you.
You're welcome. Any questions at this point? Independent samples t-test, Anova, and regression. Independent samples t-test looks at the difference between 2 groups on means scores, which tells you they have to be at an interval ratio level. Anova essentially does the same thing the independent samples t-test, except with just 3 or more groups. And then regression is prediction. We use regression to try to predict the dependent variable based on the independent variables. Clear as mud. And we'll keep, I do like this data set, so I want to keep using this data set on some examples so we can get really familiar with it. What I'll tell you as you move forward into designing your dissertation and creating your data, you need to know your data backwards and forwards. You need to know what it means, what it's measured at, the theories behind. You need to sleep with your data practically, because you have to make these decisions about it. There truly is no just clear cut, with the exception of a few things, of what you do with your data. You have to be the expert, and you have to be able to determine what you're going to run, why you're going to run it, if you've got to clean up your data, whatever you have to do, and always have that supporting evidence from the statistic gurus out there to support the decisions you make. So it really just comes a process of just doing it over and over again. And then people saying, well, what about this? Or what about this? Or what about that? Because you can take multiple roads to get to the same end. But that's what you just really have to be comfortable with your own data to go in and make all these decisions. So people who pay to have a lot of people will pay to have their statistics run for their dissertation. And when they get up there and get ready to defend it, man, if they're asked questions, they can't answer it because they don't know their data. So that's if I can give you any advice, that's one advice I will give you is know your data backwards and forwards and be able to answer those questions about it, because you become the expert at that point in time. It's your research, it's your data, and you're the expert. Any questions? Just need to digest this for right now. Okay, I will. Oops. Okay, I will post this presentation again, and I'll get it up quicker than normal. And then I will, what we did tonight, I'll actually put it together in a demonstration also too, so you'll have that to go over and you can reference that, okay? As well as I'll get the Anova written up, and then I'll provide you those written examples also for what we did. Anything else?
This was very helpful.
Does this work better?
Yes,
Okay.
very helpful. Thank you.
Thank you.
This was
Yeah, thank you.
super great. Like, it was so much
Okay.
easier to understand everything if I was able to do it myself.
Okay, and that's what we'll keep doing then, okay? And if we need to go back over things again and again, that's perfectly fine. We'll do that. Okay, that's what I wanted to know. If this works for y'all, then this is the way we'll do it. And of course, then you'll have the recording too, and you can go back and look at it.
Yay.
All right, any other questions for tonight? Okay, if not,
Homework 2 up on by Sunday night, right?
do what?
Homework 2 up Sunday night.
Yes, this next Sunday night, yes. And then I'll get homework 3 up for y'all this week. I'm hoping tomorrow, if nothing happens. My refrigerator went out yesterday, but you know, that's my challenge for March. So tomorrow, if nothing happens, I'll be able to get the homework number 3 up and ready for you to go and all of that. So that's my goal for tomorrow. All right, y'all good? Y'all rock stars? Absolutely. Okay. Well, I have another class at 7:45, so I'm going to hop off, and like I said, I'll get this recording up tomorrow, get my copies of the outputs and the writing written up and all that, and get that to you guys so you'll have that. And then we'll go from there. And if you have questions between now and Sunday, let me know, and we can certainly hop on and go over it, anything, okay?
Cool. Thank you.
All right. Y'all have a great rest of the evening.
You too.
Okay.